this is as lesson 7.8, compare mixed numbers, factors, and products. The goal is to relate the size of the product to the factors when multiplying fractions greater than 1. So this lesson is very similar to lesson 7.5, where we were figuring out that when we multiplied any fraction by a fraction, we got a smaller number. And when we multiplied a fraction and a whole number, we got a bigger number than the fraction, but a smaller number than the whole number. So it's a bunch of comparing again, but this time our fractions are going to be bigger than 1. They're going to be mixed numbers. And you may have noticed that we skipped 7.7. We're just skipping that just for today, and we're going to look at that tomorrow. If we did 7.7 now, I believe that would just confuse you. So we're going to actually come back to 7.7 so you can understand it a little bit more. So before we start today, let us review. The first thing we're going to do is review how to multiply fractions. So the very first thing, let's look at 2/3, and let's times it by a whole number. Okay. Well, if I saw this, I would first just want to put my whole number into a fraction and then multiply straight across. And I'd see that it's multiplying a whole number, so my answer will be less than 6, but more than 2/3. So 2 times 6 is 12, and 3 times 1 is 3. That is a mixed, or excuse me, an improper fraction. We need to change it to a mixed number. So our numerator divided by denominator, that actually equals 4. That equals 4 wholes. And so 2/3 times 6 equals 4. Now 4 is less than 6, but it's way bigger than 2/3. So we're really lucky with that. Let's review another one. Let's do 2 fractions. We'll do 7/8 times 4/7. This is really easy. Again, it's already in 2 fractions, and we're just going to multiply straight across. 7 times 4 is 28. Hopefully you did that in your head. And 8 times 7 is 56. Oh, remember, those are really big numbers, so we have to find a greatest common factor between 28 and 56. I already see one right away. I see that they both have at least a divisibility of 2. So I'm going to show you just an easy way to do it so I don't have to find my greatest common factor. I'm just going to divide it by 2 to get a smaller number. Just so I can do a greatest common factor chart without having to find the factors of these really, really big numbers. Now, if I were to take 28 and divide it by 2, well, half of 8 would be 4, and half of 2 would be 1, so that'd be 14. 2 can go into 56. Let's think here. That's one I might want to just double check. 2 can go into 5 2 whole times. 2 times, that's 4 with, no, not minus. Let's do subtraction. With 16 left over, 2 can go into 16 8 times. So that would be 28, actually. That, reason I did that is because I don't have my smallest fraction yet, but I do have it just a little bit smaller, so it's more manageable. Now I can find my greatest common factor between 14 and 28. Now, factors of 14, 1 and 14, 2 and 7. 3 can't go into 14, 4 cannot, 5 cannot, and 6 cannot. So those are all my factors, and I'm going to figure out, can 1 go into 28? Yep. Can 2 go into 28? Yes. Can 7 go into 28? Yeah, it can. The last one, 14. Can 14 go into 28? Yeah, it can. So that means that I can divide 14 by 14 and 28 by 14, and I would get 1, 14 going to 28 2 times, 1/2. Whew, that was a lot of work, and I figured out that 28 was half of 56, but I don't like big numbers, and so that helps me figure out just cutting it in half makes it more manageable so I can find my greatest common factor. Okay, so that was a review of fraction multiplication. To do your job today, you and anything with mixed numbers, we need to be able to feel comfortable with changing mixed numbers to improper fractions. So let's just do 2 quick reviews. Let's have 1 and 7/10 and change that from a mixed number to an improper fraction. Now, the first step that I do is I take my denominator, I use abbreviations here, my denominator, and I'm actually going to multiply that by my whole number. I'm going to do that first, and then I'm going to add the numerator. And that is going to equal the numerator to the problem. So let's see if you can get this a little bit. Denominator, which is 10, times the whole number, which is 1, plus 7, which is my denominator, equals the numerator. So 10 times 1 is 1 plus 7, or excuse me, 10 times 1 is 10, plus 7 is 17, over denominator stays the same. So just kind of the opposite of what we do normally, we take the numerator, divide it by the denominator to find the whole number, and whatever is left is the new numerator. Denominator stays the same. We're honestly just doing the opposite of that. We're changing it from a mixed number to an improper fraction. Let's do another one of those so you could see. Let's do 1. Oh, let's actually do 2. Let's do a bigger number than 1. 2 and 1/3. So I still follow this denominator, which is 3, times my whole number, which is 2. And I do that first because it's in parentheses. And then I add my numerator, which is 1. And then I get a numerator with the denominator staying the same. So 3 times 2 is 6, plus 1 is 7/3. There we go. Now, we're going to come back to this and practice this quite a bit. But let's go ahead and look at today's lesson, which is on page 321. Now, when we're done and I check it off, if I were you, I would put page 321 and page 322 glue it in your journal, because these are very, very good notes to take. Okay, remember, anything that I highlight you need to circle as well. You can make generalizations about the relative size of answer, remember product is answer, when a factor is equal to 1, less than 1, or greater than 1. So if you remember from the lessons before, timesing any number by 1 is going to equal the same number. If it's less than 1, a fraction times a fraction, we're going to get a lesser number. And when we times any number that's greater than 1, we get a bigger number. So we're going to use the same idea. We're going to make generalizations using numbers that are mixed numbers. So Jane has a recipe that calls for 1 1/4 cups of flour. She wants to know how much flour she would need to make the recipe as written. If she made half the recipe, so if she made the recipe as it was written, so like for one person or for one serving, if she cut it in half, or if she made 1 1/2 times the recipe. So there's 3 things that we're doing. So first thing we're going to do is we are going to draw a model within here. We are going to shade a model to show 1 1/4 scaled by 1, by 1/2, and by 1 1/2. So let's go ahead. We've got 1 1/4. Let's go ahead and show that much. I'm going to use here, because the fraction is fourths. I'm going to use, there we go. My lines are a little bit off. That's okay. Okay. So I've got 1 whole and 1/4. That's how much flour we have here. So what can we say? So let's see here. Notice here we timesed it by 1. What can we say about a product when 1/4 is multiplied by 1? Well, if we multiply it by 1, the product will be equal to the factor 1 1/4. So same thing, it stays the same. Anytime we multiply a number by 1, we get the same value. Now let's take a look if we multiplied it by half. Okay, so same thing. Let's pull this down. 1, 2, 3. 1, 2, 3. Oh, that second one always isn't working. Okay, so I've got my 1 whole, and I've got my 1/4. Now I'm multiplying it by 1/2. So remember from what we know before, if we just break this in half this way, because we did it horizontally, now we got to do it the other way. Okay. Uh-oh, did I lose my highlighted? There we go. Oh, there it goes again. Okay. So if we look here, we just cut it, and before we only highlighted going down, now we're going to highlight going across. I'm going to color in half. And where it overlaps, that is our answer. So if we count them up, we've got 1, 2, 3, 4, 5 over, well, let's figure out how many pieces we have. 1, 2, 3, 4, 5, 6, 7, 8. 5/8. That's not even a whole number. So when we multiply 1 1/4 by a fraction less than 1, we can say that we know the product will be less than 1 1/4. So when we multiply it by a fraction, we get less. When we multiply it by 1, we get the same. I wonder what happens when we multiply it by another number that's bigger than 1. Look what we're doing here. That looks a little intense, so let's do this. 1 1/2 times 1 1/4 equals. Whew. Look right here. They're going to times 1 by 1 1/4, and they're going to times 1/2 by 1 1/4. So that kind of looks like the distributive property. Let's go ahead and write that this looks like the distributive property. I remember the distributive property. It's where you can times just so they're timesing just each part of it, and they're going to add it together, which is nice. So let's take a look here. I'm still going to break it up here to show my 1 1/4. And highlight. My 1 1/4. And we are adding, or I guess we're thinking 1 1/4 times 1 with 1 1/4 times 2. So we're just kind of thinking of it a little bit differently. We took this and times it by 1 and we get this. And now we're going to do the same thing again and just times it by 1/2. You can tell why we skipped 7.7 because it gets very, very confusing. So let's do 1 1/4 again. So what we're showing here is this is right here. That's what we're showing right here. And we're going to do this in yellow so you can see. And we're just going to add it together in the green. Okay. Okay. So I've got my yellow. And I'm going to do 1 1/4. And like right when we times it by 1/2 up here, we just drew a line down the middle. And we had to color in half of that. Let's use blue. And anything that overlaps, that is our answer here. So, the marker up. 1, 2, 3, 4, 5. 5. Oh, we need the same denominator to add 5. 1, 2, 3, 4, 5, 6, 7, 8. 5 eighths. Over 1, 2, 3, 4, 5. 5 over 4. We need the same denominator. That wouldn't be 5 over 4. So let's draw another line just so we can have the same denominator here because we have 8 and 8. And so no longer do we have 5, we have 8, 9, 10. Instead of 5/4, we're equaling it to 10 eighths. So remember, it's the same. It's an equivalent fraction. We're just showing that that's how we did it. We distributed it out, did it piece by piece, and then we're going to add it together. 10 eighths plus 5 eighths is 15 over 8, which 8 can go into 15 one whole time with 7 left over. That is a lot bigger than 1/4. So that was a really long way for us to figure out that the product will be bigger, will be greater than both of the factors. So when we multiply a number by 1, it stays the same, it's equal to. When we multiply it by a fraction, we get less. When we multiply a mixed number times another mixed number, the product's going to be bigger than both of them. Let's look at another way to solve this. We're going to use kind of a number line, a diagram. We're going to use a different question. Jake wants to train for a road race. He plans to run 2.5 miles on the first day, and on the second day he plans to run 3/5 of the distance that he ran on the first day. So he's running 3/5 of that. On the third day he plans to run 1 2/5 of that same distance. Wow. What distance is greater? The distance on day 2 when he runs 3/5 of 2.5, or the distance when on day 3 when he runs 1 2/5 of 2 1/2? Wow, that was a really complicated question. And when things get complicated, we got to go back and double check to see if we understand what is going on. So he's running. He runs 2 1/2 the very first day. So that's timesing it by 1. He decides to run 3/5 of that amount on the second day. So he actually has to times 3/5 by 2 1/2 to figure out how much that is. And then on the third day, he's going to actually run more, 1 2/5 of the same distance he runs on the first day. So we're multiplying two mixed numbers together. And we're just going to, what is bigger, what is greater, the distance on day 2 or the distance on day 3? And it even kind of gives us the numerical expression right there. Again, it can be tough, but we want to make sure we really understand it. And we're going to graph a point on the diagram to show the size of the product and complete the statement. So 1 times 2 1/2. Notice we have our half marks here. 1 times 2 1/2. Oh, let me try that again. Because my 2 1/2 is right here, and I'm timesing it by 1. It'd be 1 jump. So the product of 1 times 2 1/2 will be equal to 2 1/2. It stays the same. Look what we're doing now. We're timesing 3/5 of 2 1/2. So let me find my 2 1/2. And I want to see if I have 5. I'm going to break this up into 5. Let me see. 1, 2, 3, 4. Oh, see, then we'll have, I want to show you what I just did. I just made sure that from 0 to this line here that I've got 5 equal spaces. I see 1 space, 2 spaces, 3, 4, and 5. So with my other pen, I can make that jump. That would be 1 whole, so I've got to make 3/5. So that's 1, 2, 3/5, or 3/5 of the jump. 3/5 of 2 1/2. There we go. So that's, you can tell here that 2 1/2, when we times it by a smaller fraction, our product was less than. We get a smaller number. When we multiply it by 1, we get the same number. When we multiply it by a fraction, we get a smaller number. When we multiply it by another mixed number, I bet you already know the answer to this, but let's prove it. Notice here, they changed it to the distributive property. They said, okay, we'll times 1 by 2 1/2, and we'll times 2/5 by 2 1/2. So they just said, you know what, we're just going to do 2 separate problems and add them together. That way it makes a lot of sense to us. So let's think. 1 times 2.5. That's 2.5. We made that jump already. And then 2/3 times 2/5. Oh, if you remember, that went, let me erase this to show you. This was the 2.5, and we went 1, 2, 3, 4, 5. We jumped 3 of my fifths, so I'm going to jump 3 tick marks. 1, 2, 3. Because we times it by 1, we times it by 3/5. Oh, this one's 2/5 though. So I'm going to be, I almost led you astray. Instead of 3/5, we're going to times it by 2/5, which would be 1, 2. Right there. So my answer is 3.5, which is bigger than 1 2/5 and 2 1/2. So the product of a number greater than 1 and 2 1/2 will be, you guessed it, greater than or bigger. And it's also going to be greater than the other factor. So I guess let's go answer the question. Which distance did he run more, on distance on day 2 or day 3? Well, distance day 2 he ran less, and on distance on day 3 he ran more. So 1 2/5 of 2 1/2 miles is a greater distance than 3/5 of 2 1/2 miles. Wow, that's a really, really complicated way to easily say. When I times it by 1, I get the same number. When I times it by a fraction, I get a smaller number. When I times it by another mixed number, it becomes a way bigger number. Let's do some practice problems. Okay. Let's times 5/6 by 2 1/5. We're going to decide if it's greater than, less than, or equal to. Well, first thing that I want to do is create my 2 1/5. So I'm going to make fifths. They're not really going to be even. It's okay as long as I have 5 spaces. Now I can go in with my highlighter. I've got 2 wholes and 1/5. And we are multiplying it by 5/6. So remember, that means I have to go the other way. I'm just going to go straight across. 1, 2, 3, 4, 5. You have to be very careful when you get to a part like this, because you have to maybe even do it with a ruler, so you've got the straight lines and it doesn't get complicated. Now I've got 5/6 of those. That means I'm going to overlap with a different color. If I did green, no, I'm not going to do green. Let's do, oops, the pink. Okay, so 5/6, going the whole other way. And where it's overlapped, that's my answer. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. 25 plus 25 is 50, 51, 52, 53, 54, 55. 55 over 6, 12, 18, 24, 30. Oh, well, that doesn't go there. That goes right here. 55 over 30. Let's just take a look here. That it's going to be bigger than or less than. Well, remember I times it by a fraction, so it means it's going to be less than. We've got a mixed number, and we're timesing it by a mixed number. If I remember from over here, when I times a mixed number by a mixed number, I get a greater than answer. So it's going to be greater than 2 2/3. So whenever I times two mixed numbers, my answer will be bigger than both the numbers. When I multiply a mixed number by a fraction, it'll be less than the original number. So let's look here. We have 2 2/5, and we're timesing it by a fraction, just like here. If you remember, 2 2/5 times 4/5. 2 1/2 times 3/5, remember it's less. So really, I just need to be able to say that this is less than. For this assignment, you do not have to show your work. You have to be able to answer these questions, saying, using your mind and your logic and your notes, saying, I'm timesing this 2 over 2 times 1 1/2. Is it going to be greater than, less than, or equal to that number? And if you are able to do that on your own and in your head and using your notes today, you don't have to draw a picture. But if you get the wrong answer, you will need to draw a picture. I want you guys to go ahead and actually do all of these. Number 4, 5, 6, 7, and 8, and 9. These ones are really hot ones because you have a missing one and you're going to say, wait a minute, I got a less one here, so what did I times it by? Less than 1 or greater than 1. So I'm going to go ahead and do those 6 problems today. If you have questions, which I'm sure you will, please, please, please come ask questions. Good luck.